In the field of aquaculture and fisheries conservation, the practice of harvesting juvenile tuna from the wild, cultivating them and breeding in captivity, was once a common method for tuna production. However, this approach has certain limitations, particularly in terms of its impact on the reproductive capabilities of tuna generations in the natural environment. The bluefin tuna, known as the largest species of tuna, can live up to 40 years. This species is not only renowned for its biological robustness, but also ranks among the highest in commercial value. A notable example is the Pacific bluefin tuna, which once fetched a record price of over $3 million at an auction in Japan, purchased by a restaurant owner. In today's video, Nature Farm invites you to join us as we delve into the techniques of bluefin tuna aquaculture that farmers implement to produce millions of these fish annually, meeting the high demand in the global market. I hope you enjoy this content and like the video. Don't forget to subscribe to the channel to stay updated with more top-quality videos from Nature Farm. Now, let's move on to the detailed content. The cultivation of bluefin tuna under controlled conditions for commercial purposes, commonly referred to as bluefin tuna farming, is a significant aquacultural activity aimed at supplying tuna to the global market. This process begins with the collection of bluefin tuna juveniles from hatcheries or natural environments, where parent fish are confined for breeding purposes. The young fish, often called fry or fingerlings, are raised in land-based pond systems or floating sea cages. Once the tuna reach a suitable size, they are transferred to sea cages located in coastal regions or further offshore. These cages are typically made from sturdy nets and are securely anchored to the ocean floor to ensure safety. During the cultivation process, the tuna are fed a high-protein diet, usually consisting of sardines, anchovies, or mackerel. Feeding is tightly controlled to ensure proper growth of the tuna and to maintain stable water quality. This includes rigorous monitoring of water quality and surrounding environmental conditions, aiming to provide an ideal habitat for the development of the fish. The cultivation of bluefin tuna until they reach a market-appropriate size requires an extended period spanning several years, depending on the rearing conditions and market demands. Once the fish reach the harvesting stage, methods such as manual labor or the use of specialized equipment like seine nets or scoop nets are employed. Subsequently, the fish undergo preliminary processing before being distributed to restaurants and retail outlets. Bluefin tuna is favored for its delicious flavor and tender, fatty meat, especially popular in dishes like sushi and sashimi worldwide. However, farming this species faces challenges such as disease management, maintaining water quality, and addressing environmental issues related to waste disposal. Despite these difficulties, cultivating bluefin tuna in aquaculture facilities is an effective approach to producing sustainable seafood and reducing pressure on wild tuna populations. To ensure optimal development of fish, planning an appropriate diet is essential. Nutritional programs must be designed to be balanced and comprehensive, providing adequate amounts of proteins, fats, carbohydrates, vitamins, and minerals tailored to the specific needs of the species and each developmental stage of the fish. This not only aids in the healthy growth of tuna, but also contributes to enhancing production efficiency in the aquaculture industry. Ensuring a sufficient and diverse nutrient supply through daily meals is a crucial factor in promoting growth and maintaining energy in fish. The frequency and quantity of food distributed to fish depend on several factors such as species, size, age, and feeding behavior. It is necessary to choose the appropriate type of food for the fish based on their size and feeding method, such as pellet form, flake form, or granular form. Using easily digestible and flavorful feed not only helps fish to maximally absorb nutrients, but also promotes rapid growth rates. It is essential to monitor the relationship between feed intake and fish weight gain to ensure feed efficiency and avoid wastage. Evaluating the growth rate of fish should also be combined with checking water quality and surrounding environmental conditions, thereby determining if adjustments to feed amounts are necessary. Factors such as water temperature, oxygen concentration, and water flow rate must also be considered when deciding the frequency and amount of feed for the fish. Providing too much or too little feed can lead to conditions where fish may become weakened or diseased. To ensure good health for the fish stock, maintaining clean and safe water quality is necessary, avoiding pathogens that can affect their development. A sustainable and effective fish farming strategy requires continuous attention to the health status and living environment of the fish, as well as readiness to adjust the feeding plan in response to changes. This not only ensures optimal development of the fish, but also contributes to the long-term success of the aquaculture enterprise. Join us in our upcoming program as we delve into the advanced technology and infrastructure employed in the aquaculture of bluefin tuna. This cultivation process integrates cutting-edge technology and specialized infrastructure to enhance the health, growth rate, and sustainability of the fish. For instance, an underwater monitoring system consisting of cameras and sensors is deployed to observe the biological behavior of the fish, providing valuable data on their feeding patterns and the surrounding environmental conditions in real time. This enables fish farmers to adjust feeding regimes, detect signs of stress or illness, and manage water quality effectively. The automatic feeding system, an integral part of the process, is designed to distribute precise amounts of feed at specific times, helping to reduce labor costs and ensure stability in feed supply. Additionally, some advanced systems are capable of using underwater cameras and sensors to monitor the feeding behavior of fish and make adjustments as necessary. Regarding water quality management, systems are engineered to maintain ideal conditions, such as temperature and oxygen levels, promoting a healthy environment for fish and reducing the risk of disease outbreaks. The pens and cages are constructed to withstand the harsh conditions of the marine environment while providing ample space for tuna to grow and swim comfortably. These may include features such as predator protection, underwater lighting, and nets with various mesh sizes, optimized for fish safety. To monitor the health of fish, veterinarians and aquaculture experts employ advanced tracking tools to detect diseases early and apply appropriate treatment methods. Some farms invest in breeding programs to improve growth rates, disease resistance, and meat quality of farmed bluefin tuna. In the aquaculture industry, nutritionists have developed specialized feed lines designed to meet the specific nutritional needs of bluefin tuna, Tunus thinnus, at various stages of development. The main nutritional components include high-quality proteins, lipids, vitamins, and minerals, selected from sustainable sources to optimize the health and growth of the fish. The use of these ingredients not only meets the physiological requirements of bluefin tuna, but also ensures food safety standards and environmental protection. In addition, a modern traceability system is implemented to monitor the rearing process from the juvenile fish stage to harvest. This system rigorously controls the quality of the product, ensuring compliance with safety and quality regulations, while also meeting international standards for sustainable certification. Furthermore, the integration of advanced technologies and specialized infrastructure in the farming process of bluefin tuna not only enhances production efficiency, but also minimizes environmental impact. This contributes to the production of high-quality tuna products, meeting the increasingly high demands of the global market. These systems are also key in discussing technologies and specialized infrastructure in the field of modern aquaculture. The Pacific bluefin tuna, Tunus orientalis, requires a specific nutritional regimen to ensure optimal growth, and maintain good health in aquaculture conditions. To develop muscle mass and maintain physiological functions, bluefin tuna need a diet rich in protein. Fish meal and fish oil are sources of high-quality protein, including essential amino acids such as lysine and methionine, which support muscle growth and recovery. Additionally, lipids and omega-3 fatty acids, such as eicosapentaenoic acid, EPA, and docosahexaenoic acid, DHA, are crucial for improving cellular health and immune function. These components are commonly found in fish oils and vegetable oils, providing the necessary unsaturated fatty acids for the fish. Although bluefin tuna are carnivorous, they can utilize carbohydrates as a secondary energy source. However, a high intake of carbohydrates can lead to digestive issues. Hence, a moderate amount of grains such as corn, wheat, or soybean meal is recommended to balance energy. Vitamins and minerals play a crucial role in the nutrition of tuna, including calcium, phosphorus, and a range of B-group vitamins essential for bone health, immune function, and enzyme activity. Antioxidants such as vitamin C and selenium are also supplemented to enhance immune capabilities and help the fish combat stress factors. Aquafeed producers work closely with nutrition experts to develop and improve feeds based on research and feedback, aiming to meet the nutritional needs of bluefin tuna at various life stages. Attention to the composition and quality of pelletized feed not only supports healthy growth in fish, but also enhances feed efficiency, thereby contributing to the sustainability of aquaculture operations. Pellet feed for bluefin tuna plays a crucial role in meeting the nutritional needs of this species. The main components providing proteins and lipids in the feed include fish meal and fish oil. Fish meal is produced from small pelagic fish, such as anchovies, sardines, and mackerel, while fish oil is extracted from oil-rich fish species. In efforts to ensure sustainability and responsibility in fisheries, feed manufacturers now seek sources of fish meal and fish oil from responsibly managed fishing activities. They prioritize the use of raw materials certified as sustainable by reputable organizations such as the Marine Stewardship Council, or according to standards set by the International Fish Meal and Fish Oil Organization. This practice helps to minimize issues related to overfishing and negative impacts on the marine environment. In addition to animal protein sources, pellet feed for a tuna also incorporates plant-based proteins such as soybean meal, wheat gluten, and corn gluten. This diversification of protein sources not only reduces dependence on marine resources, but also contributes to environmental protection. Pellet feed for bluefin tuna typically contains between 40% to 60% protein on a dry matter basis and plays a crucial role in muscle tissue recovery and development, as well as supporting metabolic functions. In terms of lipids, the feed contains between 10% to 20% lipids, including essential fatty acids such as omega-3, which greatly benefit brain development and the immune system of the fish. Additionally, this pellet feed is fortified with vitamins such as A, D, E, and B vitamins, along with essential minerals like calcium, phosphorus, and selenium. Antioxidants such as vitamins C and E and selenium are also added to enhance immune function and oxidative stress resistance, ensuring overall health for the bluefin tuna. Developing a balanced and suitable diet for bluefin tuna in captivity is a particularly crucial challenge. Nutrition experts and aquafeed producers must be meticulous in selecting and blending feed components, ensuring that this diet not only meets the physiological needs of bluefin tuna, but also closely resembles their natural dietary habits in the wild. Wild bluefin tuna have a varied diet, consuming a wide range of prey such as squid and small fish species, providing a significant amount of protein, fats, vitamins, and minerals. To mimic this natural diet, captive feeding regimes typically include crustaceans and plankton. However, the diversity of feed components needs to be expanded to fully meet the nutritional requirements of the fish. Additionally, although captive bluefin tuna may not fully exhibit natural predatory behaviors and exploratory activities as in the wild, integrating knowledge about bluefin tuna behavior, nutritional needs, and appropriate husbandry practices in captivity is essential to ensure their physical and mental health. Continuous efforts in research and the improvement of aquaculture practices, along with the development of dietary regimes and enhancement of living conditions, are crucial factors in enhancing welfare and ensuring the sustainability of the bluefin tuna farming industry. In the context of modern aquaculture, managing nutrition and health for bluefin tuna requires the application of extensive specialized knowledge. Bluefin tuna farmers need to establish scientific strategies for feeding and disease prevention to ensure the healthy and sustainable development of their stock. In nutritional management, bluefin tuna are provided with a diet specifically designed to meet the physiological and nutritional needs of each individual, depending on their age and size. This process involves scientifically adjusting the dosage and composition of the feed to optimize growth and overall health. For disease prevention, bluefin tuna aquaculture practitioners adhere to strict control measures to prevent the spread of infectious diseases. This includes regular health checks of the fish, quarantining new and sick fish, as well as maintaining regular sanitation of equipment and facilities. These measures help minimize the risk of disease and protect the overall health of the fish population. Additionally, maintaining the quality of the living environment within the aquaculture system is another crucial factor. Aquaculturists regularly monitor and adjust water temperature, dissolved oxygen levels, pH, ammonia, and nitrite levels using advanced filtration systems. This not only stabilizes the living environment, but also reduces stress on the fish, thereby enhancing the quality and efficiency of production. We will continue to discuss and delve deeper into the strategies and processes for managing nutrition, health, and disease prevention in the aquaculture environment of bluefin tuna in the subsequent sections of the program. In the aquaculture industry, ensuring the quality of fresh and premium feed is a crucial factor in enhancing the nutritional absorption efficiency of the fish. Farmers create an environment similar to the natural habitat by integrating structures such as rocks and pipes into the fish cages, aiming to stimulate natural behavior and reduce stress for the tuna. To effectively manage the density of fish in the cages, they sort the fish by size and move them to different cages or limit the number of fish per cage, maintaining a stable and healthy environment. The transportation of fish is conducted with great care using specialized equipment to ensure that the fish are neither injured nor stressed during the process. Aquaculture farms also benefit from the support of veterinarians who regularly check the health of the fish and administer treatment with the medications or vaccines when necessary, under strict supervision. Additionally, farmers frequently collaborate with experts and government agencies in researching and developing optimal aquaculture methods. Through this, they continuously update their knowledge and implement new initiatives to improve the health and welfare of bluefin tuna. These strategies and processes not only aim to enhance the productivity and health of the fish stock, but also contribute to the sustainability of the aquaculture industry. The use of vaccines and antibiotics in aquaculture is common, with the goal of enhancing fish health and preventing the spread of diseases. Vaccines provide fish with the ability to recognize and combat disease agents such as bacteria, viruses, or parasites, thereby protecting and boosting their immune system. The variety of vaccines used includes live attenuated, subunit, and DNA vaccines, each with their own advantages and limitations. The application methods for vaccines in aquaculture can vary, including injection, immersion, oral routes, or through feed and vaccination baths, depending on the type of vaccine, the species of fish, and production conditions. Modern vaccination systems help prevent the spread of diseases, reduce the use of antibiotics, and promote sustainable aquaculture practices by limiting the use of antibiotics in treating infections caused by pathogens such as Vibrio aramon or Streptococcus. The types of antibiotics commonly used in aquaculture include tetracyclines, fluoroquinolones, sulfonamides, and penicillins. These can be administered to fish through drinking water, medicated feed, or by injection to prevent the growth of bacteria and support the fish's immune system in dealing with infections. The use of antibiotics must strictly adhere to regulations on antibiotic usage in food production, including guidelines on withdrawal periods after treatment, to ensure that no antibiotic residues remain in the fish prior to consumption. Moreover, disease management practices in aquaculture are progressively being improved by reducing antibiotic usage through enhanced farming management, disease prevention, and exploring alternative treatment methods such as the use of probiotics, prebiotics, and immunostimulants. In this context, questions regarding health management and disease in bluefin tuna, as well as the environmental impact of farming this species, need to be thoroughly examined to promote sustainable practices in the aquaculture industry. In the next chapter of our discussion on aquaculture, we will delve into the environmental impacts of cultivating bluefin tuna, a type of aquaculture similar to other fish farming methods. Cultivating bluefin tuna offers both benefits and challenges to the environment. Bluefin tuna farms can be a solution to alleviate pressure on wild tuna populations, which are currently overfished due to the high demand for sushi and sashimi. Additionally, this cultivation promotes the local economy by creating job opportunities, increasing income for coastal communities, and supporting related industries such as aquafeed production, aquaculture equipment, and fish processing. However, bluefin tuna farming can also lead to environmental issues such as marine pollution. The accumulation of waste from uneaten food and fish feces can increase nutrient levels in coastal waters, thereby promoting the growth of harmful algae and negatively affecting water quality, as well as the health of the farmed tuna stock. Mitigation measures to reduce these negative impacts include strict management of feed input and effective waste treatment, coupled with the adoption of advanced technologies in aquaculture to optimize production processes and minimize environmental impact. Aquaculture activities at farms can lead to intermingling between farmed and wild fish, posing risks of diminishing genetic diversity and altering the gene pool of natural fish populations. Escapees, such as farmed tuna, can compete for food resources with wild counterparts. Additionally, raising tuna in crowded conditions at farms can increase the risk of diseases and parasitic infections if not effectively managed. These diseases have the potential to spread to wild fish through water or escaped individuals. Therefore, it is essential to improve the quality of feed for bluefin tuna by utilizing diverse sources of proteins and lipids to reduce reliance on natural fish feed. Farms should adopt advanced technologies such as efficient filtration and water recycling systems to maintain low nutrient levels, improve water quality, and minimize negative environmental impacts. Moreover, the selection of aquaculture sites must carefully consider water currents and proximity to special ecosystems. Government agencies and relevant groups are developing regulations and certification standards to support sustainable aquaculture practices and compliance with environmental protection regulations. Scientific research is currently being conducted, and innovations in methods are aimed at developing advanced aquaculture techniques to control diseases and improved genetics. These innovations are making the bluefin tuna farming process more environmentally friendly and sustainable. To enhance sustainability in the bluefin tuna aquaculture sector, a comprehensive approach is necessary, integrating economic, social, and environmental factors. This includes adhering to best practice standards, being open to new initiatives, and collaborating with stakeholders in the industry to move towards a sustainable future with minimal environmental impact. The role of water quality management in this context is extremely crucial. Ensuring the maintenance of optimal water quality is a core factor in securing the health and efficiency of aquaculture activities. This requires continuous monitoring and adjustment of environmental indicators such as temperature, dissolved oxygen levels, pH, and ammonia concentrations. Maintaining water quality is a fundamental factor in ensuring the healthy development of cultured species. To address nitrite levels and suspended solids, facilities often employ advanced methods such as biological filtration systems and water recirculation. These systems function to remove organic waste, excess feed, and other harmful agents from the aquatic environment, thereby creating ideal living conditions for the aquaculture stock. Enhancing dissolved oxygen in the water through devices such as oxygen diffusers or paddle wheel systems is an effective measure, especially in crowded conditions or when water temperatures rise. Regular water quality monitoring helps to timely identify potential issues for thorough resolution, thus minimizing nutrient accumulation and preventing the risk of environmental pollution in the aquaculture area. In addition, controlling the amount of feed appropriately and effectively managing waste are essential measures to prevent the accumulation of excess nutrients, thereby limiting the growth of toxic algae and reducing the risk of pollution hotspots formation. During the cultivation process, organic waste and byproducts generated from the activity of the aquaculture stock can negatively impact the environment if not timely and properly handled. Aquaculture farms have implemented wastewater treatment systems to efficiently remove organic solids and nutrients before they are discharged into the natural environment, aiming to minimize negative impacts on the surrounding ecosystem and protect clean water sources for the future. Methods such as sedimentation and biological treatment play crucial roles in reducing the impact of wastewater from aquaculture facilities on the environment. In some aquaculture farms, waste recycling includes using surplus feed and fish byproducts as feed for other species or as fertilizer for crops. This not only utilizes resources, but also minimizes waste generation. In integrated multi-trophic aquaculture systems, various species are co-cultivated so that the waste from one species can be utilized as nutrients for another. For instance, shellfish and seaweeds can be cultured alongside fish to absorb excess nutrients, thereby enhancing water quality and mitigating negative environmental impacts. Additionally, systems like aquaponics reduce waste load by recycling water and nutrients within a closed-loop system. This arrangement minimizes the need for water exchange while also improving waste management capabilities through the effective use of biological and non-biological components to maintain balance and sustainability in the aquaculture ecosystem. Aquaculture feed producers are exploring diverse sources of proteins and lipids to reduce dependence on fish meal and natural fish stocks. They are actively incorporating plant-based proteins such as soybean meal, pea protein, and various vegetable oils into feed formulations to partially or fully replace marine-derived ingredients. Thanks to the adoption of new technologies such as microbial fermentation and the production of single-cell proteins, the industry is developing viable alternatives to traditional feed components. Microorganisms like algae and yeast can be cultured to produce high-protein biomass, suitable for aquaculture feeds. In the context of aquaculture, several operations have adopted the principles of a circular economy, where waste from one process is reused as raw material for another. Byproducts from food processing or agricultural residues are also recycled into feed ingredients. Certification programs, such as the Aquaculture Stewardship Council and best practices in the industry, encourage the pursuit of sustainable feed sources and responsible supply policies. The goal of these programs is to minimize the environmental impact of aquaculture feed production and alleviate pressure on wild fish populations through the adoption of these strategies. Aquaculture operations are currently striving to enhance environmental sustainability by reducing waste and limiting the use of wild-caught fish as feed. Thus, the aquaculture industry is moving towards more sustainable and responsible development in the future. Thank you for watching the entire video. What are your thoughts on the methods used by locals to farm millions of bluefin tuna annually? Please share your opinions in the comments section below this video. Don't forget to like, share, and subscribe to the Nature Farm channel to watch our latest and most exciting videos. Goodbye, and see you again.